For this next part of the section 4.2 notes, we're going to look at how to work backwards a little bit. So instead of me giving you the angle in one of the sides, what if I give you two of the sides? Can you figure out what the angle must have been based on the trig function? If you don't remember what an acute angle is, it's an angle that is less than 90 degrees. There are also the obtuse angles, which you should have learned in geometry, which are the ones that are bigger than 90 degrees. So for an acute angle, when you're dealing with the angles inside of a triangle, you're limited by how big any of the individual angles can be anyways. So right now we're talking about finding one of those theta values that is specifically less than 90 degrees. These are values that you'll want to memorize. You'll notice for the sine ones that the values get larger, so 1/2, square root of 2 over 2, square root of 3 over 2. The cosine column uses the exact same values, they're just flipped in order, so it goes from the biggest to the smallest. And the tangent values are different. So this would be 30 different numbers you would want to learn: square root of 3 over 3, 1, and square root of 3. So these are commonly used trig values that you will want to memorize, and we'll be memorizing more of the chart as we go along. And we'll talk about other patterns and ways to help you remember them next week. So for what we're actually doing to find the acute angles given the trig function, you're going to start by looking at which trig function was given to you. So if they say sine of something, cosine of something, or tangent of something, then you'll know which column of values to look at. And the next piece is going to be finding the ratio of the sides that they gave you. So if they say sine of theta equals 1/2, then I know to look at the sine column, go down until I see the 1/2 value, and then the angle that's attached to that is 30 degrees. And then they will often ask you to give the angle in both degrees and radian measurements. Here are the first few examples we'll do of this. So they want us to find the acute angle, which means the angle less than 90 degrees, that satisfies these given conditions. And they do ask us to give the angle value theta in both degrees and radians. So first we're going to look at the cosine column, and we're going to try to find a value of 1/2. So if you have these memorized, the cosine column, once you see 1/2, the angle is 60 degrees. So my first answer is 60. And then you'll also want to convert that into radian measurement. So you're going to multiply by pi over 180. That's our conversion fact for radians to degrees. And that lets the degrees cancel out. If you simplify 60 over 180, then you'll have pi over 3. So those are the two answers, 60 degrees and pi over 3. Next, we're going to look at the tangent column and find which one has a value of 1. So here's the tangent column. Go down until you see the value of 1. That's the ratio of the opposite and adjacent sides to it. So the angle that this happens at is 45 degrees. And then we also need to convert this into radian measurements. So if you do the 45 degrees times pi over 180, this is going to reduce to pi over 4. So there are the two different ways of expressing that angle measurement. And for the last value, I didn't give you guys a column for cosecant of theta. I only give you guys sine, cosine, and tangent. So you'll need to remember those reciprocal pair facts. In this case, cosecant and sine are reciprocals of each other. So instead of having 2 over 1, the reciprocal of that will be 1 over 2. So now I can look at our column again, check the sine column, and look for a value of 1/2. And that's the first angle measurement right here, 30 degrees. If you convert that angle into radians, that's going to be pi over 6. And hopefully you'll start to memorize some of those radian measurements from their degree counterparts from using them over the next few weeks as well. This isn't necessarily a new skill, this is kind of just combining the things and putting them together. So maybe they will say solve for the whole triangle, or maybe they will just say solve for a specific missing side. You want to think about which relationship you have from the angles to the sides, and then choose the correct trig function to use. You may not need to use all of them if you're only finding one of the sides in particular. Then you're going to write the equation and use your opposite operations to solve for the missing side. So this is something that you probably did in geometry. We're just kind of putting together all of our knowledge and then being a little bit choosier about what we set up. So from this angle, they want me to solve for this side, the hypotenuse in this case, and I notice that we have the adjacent side. So from the angle, I have adjacent and hypotenuse, which means we should be using the function cosine. That's the one that gives us a relationship between those two values. So I'm going to have cosine of 37 degrees is equal to adjacent over hypotenuse. And then to solve this equation for x, I'm going to multiply both sides by x. So now I have x times cosine of 37. And then we would divide both sides by cosine of 37. This is not a value you'll be able to do in your head. You'll just need to use your calculator. And one of the most important things to check is to make sure that your calculator is in the right mode. In this case, we need to make sure that we are in the degree mode. So for now, I'm just going to round our answer to 3 decimal places. That's usually a good standard for trig functions, and I'm getting approximately 13.773. Next one, very similar idea. So they've given me one angle. This is the one I want to use for reference. I could technically figure out the other angle by doing 90 minus 41, but you might as well just start with the one they've given you. I see that the opposite side is given, and I see that the adjacent side is given. So the trig function that relates opposite and adjacent is going to be tangent. So I'll have tangent of 41 degrees equals 4 over x. Just like before, I'm trying to use opposite operations, and the opposite of dividing by x is multiplying both sides by x. And then since I'm trying to get x by itself and there's something being multiplied by it, I'm going to divide both sides by that tangent of 41. Again, make sure that your calculator is still in degree mode. So 4 divided by tangent of 41 gives me approximately 4.601. You will start to see some word problems given to you. If they ever mention an angle of elevation or an angle of depression, the idea behind this is when you're drawing your triangle, you're picturing somebody down on the ground level looking up at something up high. So in this case, they say angle of elevation from Katniss, which is 65 degrees. So it's like how far she has to tilt her head up to look at some point up above her at an elevation. You could also do the angle of depression from the other object looking down. There would be an angle of depression, but it would actually be this angle in here, and then you would have to figure out what the angle is inside of the triangle for reference backwards. So in this case, we have an angle of elevation of 65 degrees. They say that Katniss is 340 feet away from the base of a building. So this length to the base of the building is 345 feet. And this is Katniss here. And up at the top of the building, you have another character, President Snow, looking down. So in this case, we're given 2 of the values, but then they ask us for 2 things. First, they ask us how far up is our target from the base of the building. So here's the base of the building. We want to know what is that elevation. So from my angle, that's going to be the opposite side, and we know the adjacent side. So I'm going to use tangent to find that height. So I'm going to call that height value y, because I usually associate y with heights of objects, and the adjacent side is 345 feet. Now solving this one, the only thing I have to do is the opposite of dividing by 345. So I'm going to multiply both sides by 345. So in your calculator, if you enter 345 times tangent of 65 degrees, I'm getting approximately 740 feet. We'll just round that to the nearest whole number. 739.855 if you wanted to do to the third decimal. Next, the question says, what is the distance her arrow will have to travel in order to reach the target? So the arrow would be going along this diagonal path here. So in this case, we need to know the hypotenuse. Since we know both the opposite and adjacent side, we actually have a few choices here. You could either use sine or you could use cosine if you wanted to use the adjacent side. I'm going to use cosine since we did some rounding to find that height anyways. I'd rather be as exact as possible. So the cosine value was exactly 345. I will say cosine of 65 is equal to the adjacent side over the hypotenuse. So I'll call that h for what I'm missing. In this case, you do have to multiply both sides by h and then divide both sides by cosine of 65, since this time my variable's in the bottom. So I'm going to end up with h equals 345 over cosine of 65. And putting this into the calculator, I'm getting approximately 816 feet if we go to the nearest whole number, or 816.340 if you're going to the third decimal place. So now we have all the missing values they asked us for. We have the diagonal length is approximately 816 feet, and the height of the building was 740 feet. So use whatever information they've given you in the word problem. It really helps to draw a diagram to help you visualize what would be the base or the opposite sides or the hypotenuse of whatever figure they've given you. So try to draw a diagram and then plug in the appropriate numbers in the right spots. You should still have right triangles. For now, you shouldn't have to worry about doing anything else strange with those. And also, I will point out that I had another choice in finding the third side of the triangle here. I didn't have to keep using the SOHCAHTOA rules for this. Once I had two of the sides of the right triangle, I could have switched to using Pythagorean theorem. That would have been fine as well. Either way would have worked. So that's all for the notes today. Thank you.